Hi, dear children. Now we are coming to a very important topic, which is the time circuit. It is the LC circuit from which we have got oscillation for radio transmission and for radio reception. We have started with our ohmic resistance R, and I told you it is a carbon resistor or a manganese, very faithful. See, voltage and I. When voltage increase, I increase. So this is one about the ohmic resistance. Then we have a capacitance. A capacitance, its function is to store charge. 6 volt, and when I on the switch through a resistance 10K and 300 microfarad, then I will have a charging of the charge will be like this. Charge will be like this, and because voltage is charged by C is constant, so voltage and the charge there, the curve will be almost same. Now why I take 10K and 300 microfarad? Because I want you to see with your own stopwatch or with your own clock. If R is 10K and C is 300 microfarad, this time here will be 3 seconds. In 3 seconds, the charge will go to 67% of the total and it will come. And this is known as RC, time constant. And you have seen here, RC is R into Q by B, so it is R into IT. Q is IT and B is IR, so we get these seconds. So now we don't have any doubt that RC is time. See, at 3 seconds we get this, and then after a long time the voltage is constant. There is no more flow of current because the voltage is full. 300 is full with 6 volt. Now this charge also we will have the same thing. Just the mirror of the mirror of the reflection of this will get this. So from here it will go to 67% in 3 seconds, and the charge will gradually die down. Now we come to a very important one, inductance. And you know, inductance is very special. I told you why? Because inductance deal with magnet, and then it also deal with Faraday's laws of electromagnetic induction. Whenever I on the switch, there will be the flow of current. If this is 8 volt, then the current will be 8 volt by 4, which is 2 ampere. But this 2 ampere will not be immediate. It will take some 5-6 milliseconds to reach 2 ampere. So what will happen? There will be di dt. And you know, inductance is a very, very reactive coil. It never light any change of current. So it will try to oppose. It was 0 before. Suddenly it is going to 2 ampere. So there will be L di dt. And same thing also, when I discharge also, it will not light. It was 2 ampere, then I discharge it, so 2 to 0, and 2 to 0, inductance does not light change, because I told you inductance is what? Inertia coil. It does not light change. When it is 2 ampere, it wants to be 2. When it is 0, it wants to be 0. It does not want to change from 5 to 1, minus 2 to plus 3 and all this. So this is the value of the quality of an inductance. So here also, the current and time. And then if L is 12 Henry and R is 4 ohm, I will also get LR. At 3 seconds, I will get 67% and then up, and then this 33% will be here, it will go down. So this is the quality of an inductance. See here now, this is inductance. Then whenever there is a current, there will be magnetic lines of force, and then the current never goes to 2 ampere immediately. So there is what di dt. So Faraday's law say when there is a change of flux per unit time, there will be induced EMF. So here you understand all this. The inductance and the capacitance. Inductance is more complicated than capacitance. Capacitance store the charge. Inductance has got one property. It never allow, it always opposes the change, whether from 0 to 2 or from 2 to 0, anything. It opposes the change. That's why it is known as inertia element. I think you remember in Newton's first law of motion, everybody continues to be in a state of rest or uniform motion so long as it is not compelled by any external force. That means inductance always opposes change, just like in Newton's law of motion. Okay, so this is one. Now we come to a very important one. This is LC, and this is known as tank circuit. See, I charge the capacitor with a battery. So I remove the battery. When I remove the battery, I arrange this circuit. And then I arrange this, and then what do? I on the switch. When I on the switch, what will happen? This plus will try to go to this, or you may say electron will go like this. There will be change in current. There will be change because this was 0 volt. It was nothing was there. So this charge will go, electron will go, but this inductance, I told you, it does not like change. So it opposes the change. When it opposes the change, then what will happen? The flow of current will become smaller, will be less and less and less. And what did I tell you? Inductance never want any less, or it does not want any more. So when the inductance feel that the current is becoming less and less, what will happen is that it will it will make this voltage in such a way that it will draw more and more electron from this. Draw more and more electron. What does it mean? This become less and less division of electron until this become positive and this become negative. See that? See here, this was plus, this was minus, and the moment I on the switch, there is a change. The inductance will always like to oppose the change, and when it is decreased, it will try to increase, so it will draw more electron until this become plus. So I told you children, this one happened in microsecond, but I have to explain you in 5 minutes, 10 minutes, so that you understand. All this happened in microsecond. And what does it mean? Let us come to this now. See, when S is closed, electrons move rapidly from plate 2 through inductance L to plate 1. As soon as electrons flow through L, a magnetic field began to be established around the coil. As magnetic field increases, the coil, which never likes change, produces back EMF. It will oppose. Now, it opposes increasing electron flow, which soon dies down. The moment the current dies down, the inductance, now what does it do? Hey, I don't like the current to die down. Now I will try to draw more and more electron until this become positive. So now it opposes decrease in current flow, and to do this, it keeps the electron moving until it become plus and this become minus. So this is the last one. This goes on and on. The process takes place in milli or microsecond, and this is the tank circuit. In short, what does it mean? A tank circuit exhibits sorry, the tank circuit exhibit the change of zero magnetic energy to full electrostatic energy in A. Then here, zero electrostatic energy to full magnetic energy. So in the tank circuit, we have a transformation from electromagnetic energy to electrostatic energy. And I will not do this for you. This will do in BSc or in higher classes. The frequency of this tank circuit is F1 by twice pi square root of LC. And this is the most important circuit in radio communication, in reception, and in transmission. And next time, I will give you some idea of a radio reception. And I tell you, in 80 rupees, you can have a coil. This is about 10 rupees. And then a condenser, a variable one, it will be 28 rupees, plastic, dielectric. And then a diode and all. You can make your own uh, uh, crystal radio radio so that you can enjoy if you are near the medium wave transmission in your locality, local transmission, you can hear the radio and all this. This will come next time. So for the time being, remember this very important one. All happen because inductance does not like change. It does not like to decrease, it does not like to increase, and here is what we get. So thank you.